In this problem, we're told to simplify this expression using partial fractions. Because using partial fractions, we can integrate expressions like these with a lot more ease. Keep in mind the way we break down problems like these into partial fractions, it's going to be a over one of the factors in the denominator plus b over another factor. And our task is to find what a and b are and make this expression true. Well, how do we go about this? First step, clear the denominators. So we're going to do that by multiplying both sides by this denominator here, the most complex one. So doing so gives 5x minus 13 because that's gone. Now, what do we get when we multiply this first one by that denominator? Well, it simply becomes a times whatever it's missing. Here it's missing an x minus 2. Plus b times whatever this is missing, which is x minus 3. Okay, let's go ahead and simplify. So this is going to be equal, 5x minus 13 is going to be equal to ax minus 2a plus bx minus 3b. The goal of this is to get both sides looking as identical as possible. So here we have a coefficient of x minus a constant. We want to have a coefficient of x minus a constant. We don't have that yet, so we have to rearrange like terms. So on this side, we're going to have to factor these, factor the x. That gives a plus b times x minus 2a minus 3b. Notice on this left-hand side, we have 5x minus 13. We have one constant being subtracted. Here we have 2 being subtracted. We want to make it look just like this. We've already succeeded with the coefficients of x, but not the constants. So all we have to do is simply factor these in such a way that it looks like we're only subtracting one thing, not 2. So that's going to be a plus b here times quantity x minus, we want just one minus one thing. So how can I have minus something? Well, the only way to do that is if I were to factor out a minus, I'm going to be left with a 2a here. Keep in mind, this is going to be a plus, not a minus. Plus 3b. If I left this to be a minus and I distribute it, this becomes a plus. So we have to be careful. So the only way this first expression can be equal to this third one is if 5 is equal to a plus b. Because keep in mind, the coefficient of x here is 5, here it's a plus b. So they must be equal. That means 5 equals a plus b. And if I'm subtracting 13 here as my constant, and I'm subtracting 2a plus 3b there as my constant, they must be equal. 13 must equal 2a plus 3b. Okay, so how do we solve this? Well, there are multiple ways to solve this. We can figure out what a and b are in terms of the other expressions and then substitute, or we can eliminate. Let's try elimination. So I'm going to go ahead and I'm going to multiply this top one by negative 2. That gives me negative 10 equals negative 2a minus 2b. And in the denominator, I have 13 equals 2a plus 3b. Makes it easier to simply add when I have my negative 2a and positive 2a because the 2a's cancel. So let's go ahead and add those together. Negative 10 plus 13 is simply 3 equals, those are gone, negative 2b plus 3b. What's that? Well, 3 minus 2 is 1, so it's just going to be b. That gives me b equals 3. If b is 3 and I know a and b add up to 5, that's only going to happen if a equals 2. So if a is 2, b is 3, let's go ahead and plug these in. 2 over x minus 3 plus 3 over x minus 2. And that's our final answer. We can always check this by substituting R2 in for this, A, and R3 for B. And if we were to do that, the next step will be to clear the denominators, which we've done here. And here we're going to have 2, and here we have 3. And then the next step will be distributing 2x minus 4 plus 3x minus 9. What's that? Well, this is going to give us 2x plus 3x minus 4 minus 9, which is 5x minus 13, which is exactly what we had here. So that means it does work out. Notice that if we had to integrate these, they're a lot easier because the integral of a sum is the sum of integrals. So we can simply break these up into two separate integrands, and it's easier to integrate this as well as that. So that's our final answer right here. Thank you.